Graphing absolute value, you have notes 11-12. You're going to put 3, 7 for the date, and this is page 66. So we're graphing absolute value, notes 11-12, and you're going to put the date as 3, 7. Absolute value is defined as the distance from 0. And if you're talking about distance, you're not really going to have a negative answer. So most absolute values come out to be positive. The first example is graphing y equals the absolute value of x. So we're looking to find the absolute value of -2, -1, 0, 1, and 2. The absolute value of -2 is a positive 2. The absolute value of -1 is 1, 0 is 0, 1, and 2. So our graph, when we plot these ordered pairs, is a V shape. And we've talked about U shapes before. This one is actually a straight V. And we label it y equals the absolute value of x. Example number 2 says y equals the absolute value of the expression x plus 1. So -2 plus 1 is -1, and the absolute value of -1 is 1. -1 plus 1 is 0. The absolute value of 0 is 0. 0 plus 1 is 1. The absolute value of 1 is 1. 1 plus 1 is 2. The absolute value is 2. And 2 plus 1 is 3, and the absolute value is 3. We plot those points, and you see a slightly different graph. And we label it y equals the absolute value of the expression x plus 1. Example number 3 says graph y equals the absolute value of x plus 2. So we're finding the absolute value of x before we add 2. So that would be 2 plus 2 is 4. The absolute value of 1 is 1, plus 2 is 3. The absolute value of 0 is 0, plus 2 is 2, and so on. And so our picture, or our graph, looks like and you start to notice from the original y equals the absolute value of x, different things that happen to the graph when you put the absolute value in different places. Example number 4 says the graph y equals the absolute value of x minus 3. So I'm going to use the same values, -2, -1, 0, 1, and 2, in my table of values. And -2 minus 3 is -5, and the absolute value of that is 5. -1 minus 3 is -4, absolute value being 4. 0 minus 3 is -3, absolute value being 3. And 1 minus 3 is -2, the absolute value being 2. 2 minus 3 is -1, and the absolute value is a positive 1. And so we have part of our graph, and it never really makes that turn. So maybe I should keep going with 3 and 4 to see if I can get that V shape. 3 minus 3 is 0. 4 minus 3 is 1, absolute value being 1, and now it's turned and it's coming back up. So I have my V shape, and I can graph and label. So 2 last questions. For examples 5 and 6, what happens to the graph of y equals the absolute value of x when you add or subtract outside the absolute value sign? So if you have an example like y equals the absolute value of x, so if I add or subtract outside, like in example number 3, I added 2 outside the absolute value. What happened? Well, it shifts the original graph up or down, depending on if you added or subtracted. And what happens to the graph for number 6 of y equals the absolute value of x when you add or subtract inside the absolute value? So you're doing something to the entire expression, like example number 2. And that shifts our graph, our original graph, left or right, depending on if we are adding or subtracting.